All right, I'm back. We're on page 278, and we're going to start looking at a slightly different type of limit, right? So far we've been doing limits at specific values, getting specific values, right? Getting constants, getting whatever. Limits as x approaches infinity or negative infinity, which sometimes you'll get infinity, sometimes you get a finite number. Like, it's all over the place. The next thing we're going to do is we're going to look at limits where we're approaching a finite x value. So like x is approaching 3 or x is approaching negative 50, right? A finite value from the left or from the right, and we're going to get infinity or negative infinity as our answer. So we already know what these look like on a graph. They look like vertical asymptotes or infinite discontinuities if you prefer, which you should prefer because that's like a better name for it. But I understand you will never stop calling it a vertical asymptote, nor will I. I say it all the time. But I think it would be better to call it an infinite discontinuity because it's consistent, right? We have removable, we have jump, and then we have infinite discontinuities. So the basic idea here is that that's a gross color. Hold on. That one of these is going to happen. So either the limit as x approaches a from the left will be infinity or negative infinity, or the limit as you approach from the right will be infinity or negative infinity. All of this is based on a really simple concept that you kind of have to think about. So it's this. If you have a constant, like 5, divided by a really small number, it actually is a huge number, right? So if we have something like 3 divided by, let's say, 1 over 10 to the 99th, right? So 3 divided by an incredibly small number. 1 over 10 to the 99th is basically 0 for all intents and purposes. But this, if we simplify it, is actually going to be 3 times 10 to the 99th. That's a 3 with 99 zeros after it. Enormous. That idea is applicable all over the place when we're dealing with limits because we're always getting infinitely close to a certain value. And so a lot of when we do that, we end up with something that's infinitely close to 0 in a denominator. So we end up with a constant divided by something super close to 0 goes to infinity. It's huge. For the purpose of limits, it's sort of safe to say that 1 divided by 0 is infinity. The issue is we need to know, is it positive infinity or negative infinity? But like, go into the problem thinking that 1 divided by 0 basically infinity as far as limits are concerned because of limits. The other thing is a constant divided by something huge is just going to be basically 0. This is the limit as x approaches a constant divided by something huge. Like, I don't know. How would I even write? Well, I mean, it's something huge, like infinity. K divided by x to the n equals 0. This is our favorite thing. We've used this a million times. So they're related to each other, right? I mean, they're basically reciprocal ideas. So let's see. We are going to be using sign charts like crazy when we do these. I feel like I'm saying like crazy a lot in this video. I don't really know. So what we'll do is we'll create a sign chart. So the weird thing about these limits is going in that you're going to get infinity or negative infinity because you're basically looking at the zeros of the denominator like you have your whole life since algebra 2 when you first encountered this probably. So let's make a sign chart for this thing. The zeros of everything, numerator and denominator, have to go on your sign chart, which is something people often forget because it's like you're very focused on the zeros of the denominator because that's where you're going to get your limits that are infinity and negative infinity. But the numerator is contributing to the sign, the overall sign of this thing. So I'm going to put -2 and a +3. Okay, so test and regions. I know going into this that that's definitely a 0. And I also know that this is definitely a vertical asymptote. I just don't know like what the limits are to the left and the right. I just know you can't divide by 0. So it's going to blow up there, but like, how is it blowing up? So let's see. Negative infinity. If I take, well, negative a billion. If I take negative a billion and plug it in, I get a negative on the top. I get a negative on the bottom. So overall positive. So this is, I'm going to label this as a sign chart for F. Not really relevant right now, but it will be soon. And then, so I know everything is to the first degree, so there's going to be a sign change at every one of these, but I'm going to keep testing. So 0 is the obvious choice here. If you can test 0, always. So I get 2 divided by -3, so negatives. And then if I plug in a billion, I get a billion basically over basically a billion. I get a positive. So positive. Okay, so how is this helpful? Well, I know that x equals 3 is a vertical asymptote. So I know that this is kind of like happening for the function. I just found that as I approach from the left, the y values are negative. So they're going to have to go like this, which means the limit as x approaches 3 from the left is negative infinity. And then as I approach from the right, the y values are positive. There's only one way to do that. I'm going to have to go like that. So just from the sign chart, I am able to tell these limits. So here, the limit as x approaches 3 from the left of f of x is negative infinity, whereas the limit as x approaches 3 from the right of f of x is positive infinity. And I'm getting that because I know on the sign chart that 3 is a vertical asymptote. I already know that. That's an infinite discontinuity. I know that because it's a 0 of the denominator. So I know going in that I'm going to say infinity or negative infinity, but I don't know which. Then when I look at the values on the sign chart, the negatives over here mean that I'm diving down to negative infinity as I approach from that direction. The positives over here mean I'm going up to positive infinity as I approach from that direction. So using these sign charts, you can find these limits. It's like a superpower. Like if you get good at this, you can blow through so many limit problems like nothing. So get good at it. That's kind of the moral of the story. Let's see here. I already know that 8 is a vertical asymptote. That's not the question. The question is, what's the limit from the left? What's the limit from the right? And how can I use a sign chart to help me with that? So let's see. We'll put 8. This is going to be a sign chart for f. So you want to label that because eventually we'll have other things. F prime is something we've talked about. It's the slope of a curve at a point. Turns out you can do the same thing to f prime that you can do to f. So you can find f double prime. That'll be 2 little tick marks. F triple prime. You can go forever, really, basically. All right. So because of the squaring, it doesn't really matter what I do. I already know it's a vertical asymptote. So some people like to put a little circle there. I like to do it, but I always forget to do it, but I would like to do it. All right, so negative a billion, plug it in, you're gonna square it, so you get a positive. Positive a billion, you plug it in, you're gonna square it, you get a positive, obviously. Okay, so from the sign chart, I can say these limits. I can say the limit as x approaches 8 from the left of f of x, you always have to have a function there of something, is infinity. I know that from the sign chart because vertical asymptote at 8, as I approach from the left, goes positive. And then the same thing is true here for limit as x approaches 8 from the right of f of x. Also infinity. Sign charts, man, they're like going to save you so much time. You want to get good at them. Just remember, it's the zeros of the numerator and the zeros of the denominator. Like zeros of everything have to go on there. So let's see. I'm going to find these 4 limits, use a sign chart. All right, so I'm going to start off zeros of everything, right? Denominator and numerator. So -6, -3, +4, all going on my sign chart. -6, going in order. Can't stress that enough. It should be obvious, but everybody messes it up every once in a while. Also, sometimes you like just confuse yourself and you're like, -10, that's between -6 and -3. No, it isn't. But like in the moment, you might think it. So what is this a sign chart for? Sign chart for G. So we should label it as such. All right. Which of these could be vertical asymptotes? So I usually forget to do this. It's not a fatal error if you forget because the sign chart is there to help you organize your thoughts. But if your thoughts are clearer, it's obviously better. Those are going to be my vertical asymptotes. Different color. This is a 0 of the function. So it's interesting if there's a sign change there, but it doesn't really matter for the limits that I need to find, to figure out, to whatever. All right, negative a billion is going to give me negative on the top, and then a negative on the bottom left, and a negative on the bottom right. That's 3 negatives, so overall, negative. Everything is to the first power, so it's definitely just going to go positive in the next thing, negative in the next thing, positive in the next thing. But you could also test, say -5 gives me negative on the top, negative bottom left, positive bottom right, so positive overall, which is what I was expecting. So here, test 0, because if you can test 0, you should test 0. Positive, negative, positive, so negative overall, which I was expecting. Then a billion, you don't even really need to think about it. Like, that's definitely going to give you a positive. All right, so I'm looking for these 4 limits. Let's start with the limit as x approaches 4 from the left of g of x. Okay, I can see on the sign chart that as I approach 4 from the left, which would be like this, I'm going through the negative y value, so it's got to dive down. It's definitely negative infinity. The limit as x approaches 4 from the right of g of x. Forgot how to make an x. Okay, so 4 from the right, it's the positives. It's going to go up, so it's got to go to positive infinity. Negative 6 from the left, you can see in the chart, we got negative signs, which means negative infinity. So limit as x approaches negative 6 from the left of g of x is negative infinity. And then the limit as x approaches negative 6 from the right of g of x is, let me just check again. So negative 6 is here. You're approaching from the right. Those are positive values, so it's going to shoot up to positive infinity. And there we go. Okay, so we're going to talk about it on the next page a little bit, but the definition of a vertical asymptote is that the limit as x approaches c, so a function has a vertical asymptote at x equals c if the limit from the left is infinity or negative infinity, or the limit from the right is infinity or negative infinity. You just need one of those 4 things to be true. You don't need all of them. It's often the case that you get 2 of them, but you don't need that to be the case. By definition, it's just one of those limits is infinity or negative infinity. So we could say, like here, therefore, x equals 4 is a vertical asymptote. Here we could say, therefore, x equals negative 6 is a vertical asymptote. So this is a little annoying because you've known how to say what a vertical asymptote is for like a couple of years, but now we're proving it. It's like, okay, you walk into a room, you're like, yo, that function has a vertical asymptote at x equals 2, and then somebody's like, how do you know? And then you're like, check out my sign chart. You show the sign chart, you explain, coming from the left or the right, it's infinity or negative infinity, and there you go. You have proved your point, you've shown your work. So what I'm gonna do is stop this here, come back in the next video, and keep going. So I hope you are finding these helpful.